Hello, today's video will be a review, or more likely a comparison, between a couple of products, and of course one that I found out to be, unfortunately, with certain issues. The model that has issues is the UT120C pocket digital multimeter from UNI-T or Unitrend. Well, first of all, let me tell you what were my expectations regarding this particular product. I previously bought one that had a smaller set of features, and I was expecting the other model to have at least similar performance but more features. For instance, I was particularly interested in the possibility of measuring small currents, and this I saw as an advantage. Another advantage was that the model also had the possibility of measuring smaller voltages. So I was expecting a model that would behave roughly in line with others I have previously experienced and used for many years. Unfortunately, this wasn't the case, and I think that there is a design flaw in this particular multimeter. So let me show you a bit this multimeter and how it behaves, because ultimately I'm quite sure that you are interested to see exactly what we are talking about. So it's a pocket-sized multimeter. It's quite a good model, nothing to brag about or nothing to say as being inappropriate. It's one of the newer models. It features an auto-ranging capability, which means that it would automatically switch from a lower to a higher range of values, so that you don't have to constantly use the switch and go from one possibility of measuring to another. So it's quite handy, and particularly in a format that I found to be quite attractive. And it has a capability of measuring voltages, frequencies, measuring resistance, continuity, capacitors, diodes, probably also for reverse voltage, or this is the most likely feature, currents in microamps, milliamps, and you can see that it can both measure alternating currents or direct currents. So this would mean that probably you see in front of you quite an advanced unit, one that is clearly much better than the UT120C you have seen featured on the many videos that I had on the current channel you're watching. So, what I should have mentioned also was that this model had a greater accuracy. So overall, you were expecting something very good. Well, let's see what happens. The moment you're going to switch the multimeter, you're going to notice that the value being measured in millivolts drops. Well, that would be quite nice. It means that the device would have the proper reference and it would remain at around 0 millivolts. Well, it doesn't happen. As you will soon see, the voltage increases in the opposite direction. And this goes on for quite an extensive time. I had a lot of patience, and I can clearly show to you that the value can get as high as 246 milliamps. You may considering, oh, but there could be various interferences, magnetic currents, and so on. Think about it. This is still DC. We are not talking about AC voltage. We are talking about DC, which means that there would be a permanent magnetic, or of course an electromagnetic field that would occur so that the device would measure such a value. Unfortunately, this is not the case. In both situations, the one you see over here and the one you see in this picture, the multimeter had its probes just standing in the air, which would probably result in the device recording some sort of voltage, but not one that would clearly increase and in such a definite manner without any visible stop. You may wonder, okay, but is this something that is very serious? Well, it depends on what are your expectations, because if I'm going to couple closely the probes, you're going to notice that the value drops to 0, which is fine, is normal. However, I am pretty sure that there could be situations where such a value may not get to 0 or what you were expecting. And because of this uncertainty, I don't have quite a good perspective on this particular multimeter. And you may think, okay, but there may be something wrong with the environment in which I am testing. Well, this is not particularly the case, and I'm going to show to you through a different multimeter. So this is the other multimeter, and let's put it in the same range, so in the 200 millivolts range. You can see that it can get slightly to 1 or 0 decimal points the moment I'm making some movements, and probably I'm touching the device or doing anything else that results in capacitive coupling that changes, and the multimeter senses that. However, you're going to notice that the value is consistently 0, which from my expectations would lead to a device that is highly predictable. On the other side, the other multimeter slowly climbs to a value that seems to have no issue in stopping at a certain value. So I don't think that is quite the behavior we're expecting over here. And moreover, you may consider, oh, but I can calibrate the device dynamically by pressing this button, which is rel, and which would mean that all the measurements would be relative to the value that was previously set. Well, of course, everything is fine as long as you're still using the device, because the moment you're going to zero in, you're just going to see the same value increasing. And when you get back to the typical scale, the value seems to have the same amount of increase no matter what happens. You may wonder, all right, but is this something that matters a lot? It depends. As mentioned, the moment I'm placing the probes in a circuit is not probably going to be an issue, or is not going to be an issue that would affect so much measurements. However, due to the fact that I'm expecting sometimes for a multimeter or any sort of testing equipment to offer more information and more accuracy than I am able to grasp through a certain circuit, this is clearly a deal breaker. And unfortunately, I have very little that could be said about such a device. The rest of the features do not seem to have a problem, because as soon as I'm going to make a contact, there is going to be quite good latch, but you're going to notice that it's not entirely perfect. This was to be expected, because we are talking about a device that has quite high accuracy. In fact, it's a 4000 counts multimeter, while this one, the UT120C, is a 2000 count one. So the accuracy of this device is higher. Unfortunately, something is wrong. And I'm going to show to you the same measurements being taken with this multimeter. So I'm going to start it. As you notice, it's not on the millivolts range, it's on the volts range. However, it maintains a solid 0, which actually I think is very good. If you're going to think about it, the voltages we are measuring over here are in the 2000 millivolts or 2 volts range. So we are already seeing some precision and there is nothing that affects it. On the other hand, with the other multimeter, with the UT120C, which is more advanced, this is not stable. And let's see the measurement for resistance. As you can see, it gets to the same value, and I'm going to show to you exactly what happens. Okay, so I'm going to place the probe and then touch it, and let's see how solid the value is. Okay, so I don't know if you can see well the display. Okay, I think that is quite solid, so a very good latching. I would say that latching is even slightly better to the one UT120C. I will attempt to make the same contact. I'm not entirely sure if I will be able to, just to have a rough comparison. So I take the UT120C and I'm making the same point of contact roughly. Okay, so I could have placed it in my hand and made a better contact and it would latch. So this is not an issue. Regarding current, I'm expecting current measurements to be quite all right. I don't think they are going to be affected by the issue I noticed on the volts range, because as you can see, the value clearly gets to 0. And particularly when we are talking about microamps, it should point to a device that doesn't have an issue. Unfortunately, as I said, the millivolts measurement capability raises some doubts about the device. Okay, so let's get back to the voltage meter. Okay, and the value increases again. As I said, probably some much more knowledgeable electronics or technicians around could be thinking about using a bleeding resistor or a resistor that could be placed between the probes so that the voltage would remain stable. I think that would be a possibility, although I think that the range or such a resistance being used should have been at a value beyond 20 or I think 40. Let me see, 40. Yes, something that would be above 40 megohms, because since your measurement can be at up to 40 megohms, I think that this is going to affect your measurement. So you have to think about a resistance that is of even higher value. And I'm not entirely sure if such a resistance would actually maintain a solid 0. Possibly one that, I don't know, is around 100 megohms, but a 100 megohms resistance I don't think is quite easy to find. So ultimately, I think that there is another way to improve the design, and that would result in the problem being solved. However, I want to show to you another failure of this design, and I would like to show you this capacitor right here. Since the battery has to be slid from beneath this contact, that of course is a cross contact, it means that you can very easily hit or damage or lift that capacitor from the board, which surprisingly doesn't quite affect the device. But I have seen one, and this is the one you're seeing, where this capacitor has been had its contact pad lifted off the board, probably because during manufacturing or during assembly, more likely during the assembly, someone slid the battery wrong, and it made a much stronger impact on this side and actually affected the capacitor. However, this hasn't affected at all the device's operation. So I'm not entirely sure what may happen. Some of you, I think, can be way more knowledgeable than me. However, the end result is, as noticed, that I have my doubts about this product's operation. And think about it, 90 millivolts. 90 millivolts is already at least 2 digits of this other meter. So it would be probably 3 digits as soon as it gets to 100. However, this is not the case. This is solid, this is not. So I'm not entirely sure what happens. However, I wanted to show to you exactly why you shouldn't buy the UT120C, despite its multiple features and despite it being entirely similar to UT120A in terms of at least some of its features, despite not having an ammeter and a capacitor tester. However, the voltage range is totally unpredictable. And as I said, since I'm expecting measuring device to be highly accurate, and me being probably the person that is not too knowledgeable enough, when my multimeter has this issue, I don't want to think about other situations where the values may not be accurate. However, I have to show to you at least how voltages are actually measured, because I'm not expecting a definite difference between multimeters. So I'm going to show to you all three measurements. It doesn't matter what kind of polarity I'm using. Let's just change for the sake of it, plus being on the red, which is the typical situation, and minus being the black. Okay, so it is around 1.514 volts, 1.5 volts. Okay, that is the value I was expecting. Now let's see what a similar multimeter shows. Of course, the venerable UT120C that has been featured on so many occasions. Okay, on the 2 volts range, so the same capability. 1.518. The difference is very small, and I'm not expecting this to be a particular concern. You may consider, oh, possibly something like the last decimal point, the latest decimal value, so something in the range of 1 or 1 to 3 millivolts may be off. I'm not entirely sure if this is the case. Let's see what the other measurement shows. 1.511. So a bit below. Since all multimeters have their own internal resistance, these values may not be entirely possible to reproduce no matter what happens. So 1.518, 1.511. I think this is the roughly this is the value. So there is a bit of variability. I'm not entirely sure if one of these voltages is more accurate compared to the other, if one of those measurements is good. But I think they're roughly at the same value, and I think this is enough. However, as noticed, due to the previously mentioned aspects, I cannot recommend to you buying 120C multimeter. So if you think about buying such a small device, I think the 120A is a safe bet. I'm not entirely sure if this is one of the major reasons you haven't seen that many reviews of the 120C on the internet, or it's simply due to the fact that very few persons actually found a use for measuring very low currents and paying a slightly higher price than the one for the 120A model or the B model. However, as I see it over here, there may be some circumstances where measurements may not be accurate, and due to this I cannot have that much confidence in using this device, despite being very attractive and despite having a solid set of features. Because if you look on the data sheet that you can find over here, you're going to notice that, okay, let's see if I can make, okay, slightly good focus. Just let me put the device back in its package. Okay, good. If you're going to look on the specifications, you're going to notice that it has the ability of measuring DC and AC currents, resistance, capacitance, which was of course what I mentioned before, and the rest of the features are similar to the 120A and 120B models. Even the frequency range is the same, so from 10 Hz to 100 kHz. So ultimately, I think that given the current circumstances, and also I have to mention something else. I have been watching very carefully at the board and what is mentioned on it. And the same date of 2022, I think it's the 6th of January, or it may not be if the date is not printed in the European system, or it is more in the American one, and then it's probably year, day, month. It could be the 1st of May. Well, it doesn't matter that much. Both of these meters, the one that you have noticed as being with a bad behavior and the UT120A, have the same printed date on the board. And more, I haven't seen just a single UT120C exhibiting this issue, but 3 others as well, 3 others. So keep that in mind, that it's clearly not a localized problem. It's not one that can happen just with a single meter. It's probably one that should have resulted in recalls, or at least a different approach from the manufacturer. But I'm pretty sure this is not going to happen. Again, we are not talking about European or American-based manufacturers. We are talking about Chinese ones, so probably it's not such a major concern how well those devices operate. Because, as mentioned, they operate quite well, but this uncertainty factor for me is a deal breaker, particularly when I think about such old meters and others you can find very cheaply in online or physical shops that you can buy, and still they do not have this issue even on the millivolts measurement range. So yes, I think I cannot recommend such a product. You have to be careful, and if you want, however, to purchase it, you can do so, but I'm not going to be entirely confident about its abilities. So take that into consideration. I hope you enjoyed the video, and thank you very much for watching.